First, introduction. Why arrays? So far, when we wanted to store multiple related pieces of data like 5 student scores, we had to create separate variables, integer score 1, integer score 2, integer. This quickly becomes unmanageable for many items. Imagine needing to store 100 scores. This is where arrays come in. An array is a collection of elements of the same data type, stored in contiguous memory locations. Think of it like a list or a row of identical boxes. Second, declaration of one-dimensional arrays. Declaring a one-dimensional array tells the compiler. Data underscore type. What kind of data the array will hold, e.g., integer, float, char. All elements must be of this type. Array underscore name. The name you choose for your array. Size. The number of elements the array can hold. This size must be a positive integer constant. Example. Integer scores 5. This declares an array named scores that can hold 5 integer values. Important note. In C, array elements are stored in memory next to each other. This is a fundamental concept. Third, initialization of one-dimensional arrays. There are several ways to initialize an array. A during declaration with values. Integer myNumbers 3 equals 10, 20, 30. This creates an array myNumbers of size 3 and assigns 10 to the first element, 20 to the second, and 30 to the third. Implicit sizing, integer myNumbers equals 10, 20, 30, 40. If you omit the size, the compiler automatically calculates it based on the number of initializers provided. Here, myNumbers will have a size of 4. Partial initialization. Int myNumbers 5 equals 10, 20. If you provide fewer initializers than the size, the remaining elements are automatically initialized to 0 for numeric types or null characters for character types. So, myNumbers would be 10, 20, 0, 0, 0. B after declaration, assigning values to individual elements. You can assign values to elements individually using their index. 4. Accessing elements in one-dimensional arrays, indexing. To access an element in an array, you use its index or subscript. This is the position of the element within the array. Crucial point. C uses zero-based indexing. This means the first element is at index 0. The second element is at index 1, and so on. For an array of size n, the last element is at index n-1. Example. For integer scores 5, scores 0 refers to the first score. Scores 1 refers to the second score. Scores 4 refers to the fifth and last score. To assign a value, scores 2 equals 85. To read a value, printf the third score is %d, scores 2. Fifth, example code, declaration, initialization, accessing. Sixth, conclusion and next steps. Arrays are fundamental. They allow us to manage collections of data efficiently. Remember, they store multiple values of the same type. They use zero-based indexing to access elements. The size must be a constant during declaration. In our next lesson, for point 02, one-dimensional arrays. Example, storing a list of scores.